Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to YouTube channel Chandan Physics. In this video, we are going to discuss Miller indices. Let's begin. Let me consider the lattice points. In two dimension. When we connect these lattice points, we can connect it in that way, this way, any kind of ways are there to connect these lattice points. As we know, the crystals are anisotropic in nature. Anisotropic means it is independent of directions. All the physical properties of crystalline solids are different in different directions. But when we are studied about the crystallography of these crystalline solids, it is difficult to analyze various kinds of properties as it is anisotropic in nature. Therefore, in order to study the basic properties, let an example of diffraction of crystalline solids. We have to consider the parallel planes. To construct that kind of parallel planes, it is difficult to us. To avoid such kind of difficulties, a scientist named Miller came into picture. According to Miller, he used a method. That method basically named as Miller indices, which one are used to specify the directions and planes in lattices or in crystals. Miller indices are used to specify directions and planes in lattices or in crystals. So, how we have to find out the Miller indices? What will be the procedures in order to finding the Miller indices? We write some procedures here. First of all, find the intercepts of the plane along the axes x, y and z in terms of the lattices consist of A, B, C. A, B, C, when we are dealing with translational lattice vector, A, B, C are the lattice vectors. We can understand it by taking an example. Let me take an example. To understand how to find out the Miller indices. First one, find the intercepts of the plane along the axis x, y, z in terms of lattice constants A, B, C. The coordinates x, y, z having the coordinates are like A, 2A, 3A, 4A, so on, and B, 2B, 3B and so on, C, 2C, 3C, 4c like this. Let we take a plane ABC and it intersects that xyz plane at the points A, B, C. A, B, C. ABC is that plane which intersects x, y and z axis. X axis at 2a, y axis at 3b and z axis at 3c. Next point, the coefficients of the intercepts are noted separately. First ABC plane, ABC plane intersects x, y and z axis at 2a, 3b and 3c respectively. Next, the coefficients of the intercepts are noted separately. So, the first the intercepts are 2a, 3b and 3c. The coefficients of the intercepts, coefficients of intercepts x axis the coefficient 2, y axis the coefficient 3 and z axis the coefficient, here is the 3. Next point, find the reciprocal of these numbers, means taking the inverse. So, the reciprocal of these numbers, inverse of the coefficients, inverse or reciprocal of coefficients 1/2, 1/3 and 1/3. Next, the fractions are multiplied by a suitable number so that all fractions become integers. If the reciprocal are fractions, then we have to multiply a suitable number in order to avoid that fractions. In other words, we can say at least a common denominator or a multiplier is used, or LCM we can taken into consideration, and multiply is by the LCM. In that of case 1/2, 1/3, 1/3, we have to take the LCM of the denominators. Here the LCM of denominator is 2, 3, 3. The LCM is 6. And then multiply each by this LCM, multiplying each term by that of LCM. multiply the fractions by 6 so that they become, when 6 is multiplied by 1 by 2 it will be 3, 6 is multiplied by 1 by 3 it will be 2, and again 6 is multiplied to 1 by 3 it will be 2, and these integers are written in the form of SKL, and that notation of SKL within this bracket denotes the set of all planes that are equivalent to SKL by the symmetry of that of given lattice, and the three integer SKL nothing but the Miller indices. Therefore, Miller indices S K L is equal to, we write it as 3 2 2. An important point you have to notice here, when we are writing the Miller indices there will be no commas are used. So in that of section we say the Miller indices is 3 2 2. Now that the definition of Miller indices, procedures we have to follow to finding the Miller indices, an example to taking the Miller indices. Next, some important points we have to remember in order to dealing with the Miller indices. Note that, note so there will be no such comma is used when we are writing the notation of Miller indices. So a comma or a dot between any two number may be avoided when writing Miller indices. Next point, when we taken the Miller indices of x axis, the positive x axis, is represented as 1 0 0. Similarly, positive y axis is represented as 0 1 0, and the z axis is represented as 0 0 1. Similarly, for negative x axis, the negative x axis is represented as we just use a bar sign on that, 1 bar 0 0. Similarly, for negative y axis is represented as 0 1 bar 0, and negative z axis is represented as 0 0 1 bar. So, how we read that a Miller indices? Let a Miller indices of a particular plane is given. The Miller indices for a plane, it is 101, is read as, we read it as 101, and we do not read it as not as 101, 100 and 1, 101. These are some basic important notes related to Miller indices. Again, some common notations we have to follow. Common notations also we use in order to determining the Miller indices. The notations, when we write S, K, L, it represents the direction, it represents a lattice point, Here the commas are used to signify the points. Next, if it is written as S, K, L within this bracket, it represents the directions, it represents the direction. If we write it as in terms of the notation S, K, L within this bracket, then it represents the family of directions, it represents the family of directions. Another way to represent, if it is S, K, L within this bracket, then it represents a plane, it represents a plane. If S, K, L within that curly braces, then it will be represented as, it represent a family of planes. Next, taking an another examples to show the Miller indices. There will be the lattice points, as x axis, y axis and z axis. These are the lattice points. If we prefer a plane here, that is the lattice plane, and that plane can be represented in terms of Miller indices as this is x axis, this is y axis, and this is z axis. If we write the lattice directions as x as A, y as B, and z as C, so that shaded plane intersects x axis at A, y axis. In theoretical manner, there will be no such intersection of that plane to that of y axis, but it intersects at infinity, and again that plane intersects c axis also at infinity. So, the intersections as A, infinity, these are the intersection points. Then you have to taken the reciprocals 1 by A, 1 by infinity, 1 by infinity. In order to taken a number here, we have to just multiply A on each term. So, when A is multiplied, so it will be 1, then it will be 1 by infinity A, that is 0, it will be 0. Therefore, Miller indices of the shaded plane that is represented as HKL as 1 0 0. No such comma is used in order to taken the Miller indices. So, here with the help of this video lecture we understand the basic concept, that is Miller indices, procedure to finding Miller indices by taking an example in order to understand the procedures to find the Miller indices. Some notes, or we can say some basic point we have to remember in order to write that Miller indices, and some common notations basically used for writing Miller indices, and another example to show the Miller indices, how we use Miller indices to calculate for a particular plane. So, with this useful and informative notes, let me wind up this session. Thank you.